Alhamdulillah. اللهم لا سهل إلا ما جعلته سهلا وأنت تجعل الحزن إذا شئت سهلا. Wallah, nothing is easy except what you have made easy. Wallah, if you wish, you can make this difficult task as the easiest one, inshallah ta'ala. Okay. So are you ready with your textbook, a rough book, and a pen? Okay, Alhamdulillah. It's a closed book test. Kindly do not open your notes book, please. Okay, beta? Chalo. So I'll quickly revise what we had discussed. What is a quadrilateral LIBOR? What did we say? What is a quadrilateral?
Shape with 4 sides, 4 angles, and 4 vertices.
Yes, it is a shape bounded by four vertices, 4 angles, and 4 sides, right? Alhamdulillah. Okay. What did we study in the quadrilaterals? How many figures do we have in the quadrilateral? What shapes do we have in the quadrilateral? Liba? How many shapes are there in the quadrilateral? I cannot hear you. Okay, yes. Yes. Okay, Alhamdulillah. So which we are discussing in the syllabus right now?
Parallelogram.
Okay, parallelogram. We discussed, where you remember, we discussed the 4 theorems in a parallelogram, right? What are the 4 theorems that we had discussed in parallelogram? Theorem number 1. Come on, Peter.
A diagonal of parallelogram divides it into 2 congruent.
Yes, the diagonal divides the parallelogram into 2 equal triangles, right? And what did we discuss in the theorem number 2?
In a parallelogram, opposite sides are equal.
Excellent. Opposite pair of sides are equal, right? Opposite pair of sides are equal. Okay, the third theorem, beta.
In a parallelogram, opposite angles are equal.
Excellent. Opposite angles are equal. Which is the fourth theorem, beta?
The diagonals of parallelogram bisect each other.
Yes, the angles of the parallelogram. What do bisects? Diagonals, right? The diagonals of the parallelogram bisects each other, right? Bisects matlab they divide each other into perfect halves, right? So these were the 4 theorems. And what more did we discuss here, Laiba? We had to discuss about the converse of those theorems, right? Okay, Alhamdulillah. All of these theorems are done. Do you remember how to prove the first theorem? Quickly tell me how to prove the first theorem, Laiba. How did we prove the first theorem? It is just to prove the congruency, right?
Yeah.
Yes, just to prove the congruency in the 2 of the triangles. How did we prove the congruency in the 2 of the triangles? Just tell me, what was common here, beta?
AC.
Equals AC. This is the first side. Tell me what else? What else? What else did we use to prove this congruency in these two triangles? These 2 are parallel in a parallelogram. If these 2 are parallel, then what else comes into picture? This angle and this angle is equal, correct? Angle C and angle A.
Yeah.
And what else? What else? Another Z is formed here, right? This Z. Or the Z in this way. Z matlab alternate angles, right? Do you remember what did we discuss about a parallelogram? If 2 sides are parallel, this and this are parallel, then alternate angles are equal, right? So this angle and this angle is equal. And if this Z is formed here, this and this alternate angles are equal, right? So which postulate did we use to prove this 2 triangles are congruent? Which is the postulate that we used? One side, 2 angles. Which is the postulate?
AS.
ASA, excellent. One side to ASA postulate we have proved to prove that this triangle is congruent to this triangle, right, Laiba?
Yes.
Okay, Alhamdulillah. So this is the only theorem that you have to prove. You do not have to prove any other theorems. Okay. Okay.
Yes.
I need this class to be interactive, please. This is the test, and you have to answer every question, inshallah ta'ala. Just try to answer. If it gets wrong, no problem. I'll help you out. Okay. Let's not consider the example problems. Let's just go to the exercise problems. Just keep your textbook open and notes closed, please. Okay. Notes closed, Laiba?
Yes.
Okay, Alhamdulillah. Come on, solve this problem for me, beta. You just have to tell me and solve. Can you write on the screen?
What?
Can you write on the screen?
No, it's actually hard. House.
It's difficult to write on the screen. Okay, then write. Take a rough book, write it, and send me the answer right now of in the phone. Or you can switch on the video and you can show me the answer on the video call. Whatever is easier for you, you can do it. You have to solve this problem. Solve this problem in your rough book and send the snapshot, or you can solve it now and send it to me and show it to me on the video. Whichever is easy, please do it. You have to solve this right now in your rough book.
Okay.
Okay, while solving, please say it out, say it aloud.
So, first we draw parallelogram.
Yes, okay. Excellent.
And then,
Name it A, B, C, D.
yes, and then we dot two diagonals.
Yes, excellent.
So, in the diagonal, BD and AC are equal. The diagonals.
It's given. Is it given?
Yes.
Because we know it from the theorem, right? Okay,
Yes.
alhamdulillah. Yes.
And then AB is the common side in both the
Yes. Excellent. Excellent.
triangles. And then
Then what more, Peter? Common side, opposite sides are done. Is the opposite sides done?
We need to show that all sides are 90
First,
degrees.
congruency. Yes, you have to prove the congruency through which postulate, Peter? Which postulate did you use now? How many angles did you use? You just used one. Yes. You did not use any angle, I guess. You just used the sides. This side, this side, this side, these two diagonals, one common side. Right? Which two triangles did you consider? This triangle and this triangle. Okay. Okay, what else, Peter? What else comes into pictures? CPCT. After that, you will find the CPCT, right?
Angle A is equal to angle B.
Yes, excellent. After CPCT, what comes into picture? Then we know that angle A, this angle, the interior angles of the triangle, angle A plus angle B is equal to 180 degree, right? Then what we do is angle, we know that angles, opposite angles are equal, right?
Yes.
So what do we do? Angle A is equal to angle B. So what happens is 2 times the angle A is equal to 90 degree. If 2 times the angle A equals to 90 degree, 180 degree, then angle A equals to 180 degree divided by 2. What is 180 degree divided by 2, Laiba? 90 degrees. So angle A becomes 90 degree. If angle A is 90 degree, then what does angle B equals to? Because we already know that angle A equals to angle B because of the CPCT. So what we write is angle B is equal to angle B is equal to 90 degree. If the angles are 90 degree, then it is surely a rectangle, right? It is surely a rectangle. That's all. Then, is it not done? Yes, it's done, right? Alhamdulillah. So you can just send me the snapshot what you have done in the rough book, what you have solved in the rough book. Okay. Okay, this question is enough. We'll see the next question. Okay, this one, beta. This is quite easy, I guess. ABCD is a square. Okay, no need of this. We'll see this one. This is quite easy. Okay, Laiba, come on, prove this. Okay, alhamdulillah. Okay, excellent, beta, excellent. Chalo. Just received the photo. It's fine, alhamdulillah. Now, please solve for the fifth problem. The parallelogram ABCD, there are 2 points P and Q. Okay, they are taken on the diagonal BD such that DP is equal to BQ. Can you please solve this? You just have to prove triangle APD is similar to triangle, congruent to triangle CQB. Are you doing this? Are you solving it? It's quite easy. It's very easy. Just two triangles. Where are the triangles? Triangle APD and triangle CQB. This you have to prove. How will you prove? This side and this side are equal, right? How to prove congruency, Laiba? I cannot hear you.
We'll see. We'll take DP is equals to BQ. It's given.
DP is equal to BQ. How is it so, beta?
It's given.
Yes, excellent. It's given. TP is equal to BQ. First thing. The second thing.
AD is equals to BC.
We are taking these two triangles only. BC is equal to AD. Excellent, excellent. AD is equal to BC. What is the reason? What is the reason, beta? What is the reason do you give here? It is the sides of the parallelogram, right? Opposite sides of the parallelogram are equal. Okay, what else, beta?
Then
Z. Can Z be applied here?
angle B.
Yes. Which angle? This angle is equal to angle D. Excellent. This is alternate opposite angles. Alternate opposite angles are equal because of the parallelogram. This one, right? If two line sides are parallel, then alternate interior opposite angles are equal. Okay, this is done. So which postulate did we apply here, Olaiba? Side,
SCS.
side, angle, side. Excellent. So SAS postulate we have applied here. And what more comes into picture, Olaiba? This
AP
is done.
is equals
Then
to
they have asked you
CQ.
to prove that AP is equal to CQ. Yes, AP is equal to CQ. Why is it
CPCT.
so? Because of CPCT. Excellent. This is the reason you have to give. See, what does CPCT mean, Laiba? Corresponding
Corresponding parts of
of
congruent
congruent
triangles.
triangles. Excellent. Then what more? You have to prove AQB is congruent to triangle CPD. How will you prove this? AP, sorry, AQB, this triangle. Yes, right? AQB
Yes.
and CPD. Tell me the reasons urgently, better. So this AB parallel to CD and also the opposite sides of parallelogram are equal always, right? First thing is proven. What is proven now? AB is equal to DC. This is the first thing. This is the what do we say? Sides of parallelogram. Correct? The next thing. What is the next thing, beta? Can we not use the
Take
alternate
one
angles?
angle.
We can use the alternate angles. Excellent. We can use this ABQ and PDC as an angle. Yes, you can use alternate
AB.
angles. And you also can use A and C, right? You can also use these two angles as well. Okay. Or also you can use any other thing. Can you use any other thing here? DP is equal to BQ is given. You can also use this. You can also use the SSS postulate or you can use the SCS postulate, whichever is applicable for you. You can use that and you can just prove the congruency in these two triangles. Okay, that's all. And next we have AQ is equal to CP. Where is AQ here, beta?
AQ is equals to CP because of CPCT.
Is it equal? Yes. Why is it so? CPCT. Excellent. Next we have then they have to told you to prove APCQ is a parallelogram. How will you prove APCQ is a parallelogram, beta? What you should have? You just have AD is equal to BC by CPCT, CD is equal to AB by CPCT, or how we can prove that this is a parallelogram. Okay, sorry, we want to prove this one, right? Chalo, to prove that this is a parallelogram. How will you prove it? We know that AP is equal to QC from the CPCT, right?
Yes.
PC is equal to AQ. We know already from the parallelogram from this, and we also know that these alternate angles are equal. Why are these alternate angles equal? Because this is equal to this, so the interior alternate angles are always equal. Okay, how will you prove this, beta? Which postulate or what will you apply here to prove this?
Don't we just write that it's because all sides are equal?
It is because all sides are equal. Excellent. We can write it in that way as well. AB is equal to this much is equal to this much. This is equal to this much. That's all. This is enough for the proving the that this is a parallelogram. Okay. Can we solve this? No, I'll see the next problem. We'll solve this because we had not solved it. I had given you for the homework this one as a homework, right? Come on, let's solve this. Okay, Elaba, you have to solve this for me. Okay, the question they have given is ABCD is a trapezium. What does a trapezium mean? This is a trapezium. Okay, we have already discussed that there are different types of quadrilaterals. This is one of the type of quadrilateral, right? Trapezium is a quadrilateral. So AB is parallel to CD. They have already given that AB is parallel to CD. And AD is equal to BC. They have already told you that AD is equal to BC. These two sides are equal. Okay, but this and this sides are not equal, right? AB and DC are not equal. They are just parallel. Show that angle A is equal to angle B. How will you show angle A equals to angle B, beta? How will you show angle A equals to angle B? What you have to do here, Alaiba? What we are going to do? They have drawn a construction here. Have you seen this? They have made an additional construction. What they have done here is they have made an additional construction and just they have constructed a triangle. Have you solved this? Have you solved this as a homework problem?
Yes, I think I did.
Yes, yes. How did you prove this, beta? Do you remember if you construct this, then what is this? This is equal to this, right?
Yes.
Yes, this and this are equal. If this and this are equal, if this and this are equal, what did we construct here? We constructed a parallelogram, right?
Yes.
Yes. So AD is equal to EC, but we also know that AD is equal to BC, right? First, we know that AD is equal to EC. Then we also know that it's already given, right? It's given in the question AD is equal to BC, right? AD is equal to BD. From this to what we can infer? If AD is equal to EC and AD is equal to BC, then EC is equal to BC, right? This and this are equal, then this and this are equal. If this and this are equal in a parallel, in a triangle, then what happens, beta? If this is equal to this, if opposite sides are equal, then opposite angles are equal. Which angle is equal? CBE is equal to CEB, right?
Yes.
So if these two angles are equal, then what does this stands for? Interior angles in a what do we say, in a parallelogram? Angle A in a trapezium. Angle A plus angle CBE. Angle A plus angle CBE is equal to 180 degree. Right? Right, beta? The angles on the
Yes.
same side of the trapezoid are always equal to 180 degrees. So we can write CBE as CEB. This and this are equal. So what did we write here, beta? Angle B plus angle CBE is equal to 180 degree. Sum of interior angles, angle B plus angle CBE, these two are equal to 180 degree, right? This. So when you add this two of this, you will get, you also know that angle A is equal to angle B. It is already given. So this is the thing that you have to prove. Angle A is equal to angle B. Right? How
Yes.
did you prove this? You just have to add of this or subtract this. If you subtract of this, 180 minus 180, you'll get angle A is equal to angle B. Just you have to just substitute in this both of the equations. Okay. The next question. What is the next question? Angle C is equal to angle D. How will you prove it, Vita?
190.
Because it is already given that angle A equals to angle B, that we have already proved. So we know that in a trapezium or anything, if we add the interior angles, then what we'll get? Angle D plus angle C is equal to 180 degree, and also angle A plus angle B is equal to 180 degree, right?
Yes.
Yes, so angle A plus angle B is equal to 180 degree, and this both are also equal to 180 degree. Angle D plus angle C is equal to 180 degree, right? Right, all of these are in the same line, right? So instead of angle A, we can also write angle D as angle A and angle B is equal to 180 degree. Angle D plus angle C is equal to 180 degree. But we also know that angle B is equal to 180 degree. Sorry, angle A is equal to angle B. So angle A plus angle A gives you 2 angle A is equal to angle D plus angle C. Or we can also write this as, instead of this, we can write it as just angle A plus angle B is equal to angle A plus angle C. Can we not write it as this? Angle A plus angle D is equal to angle A plus angle C. We can write it as this. Do you know why? यहाँ पे देखो बेटा, angle A plus angle D is equal to 180 degree. Angle B plus angle C is equal to 180 degree, right?
Yes.
We can write, instead of angle A, instead of 180 degree, we can write that these both sums are equal to 180 degree, right? But we also know that angle A plus angle D is equal to angle A plus angle C, correct? So angle A cancels out. You know the how to cancel it out. If it's the same angle on both sides, you can cancel it, or you can send it this side. Angle A minus angle A gives you 0. So angle D is equal to angle C. That's all. Okay. Next, we have to prove congruency in triangle ABC and triangle BAD. How will you prove the congruency of triangle ABC and triangle BAD? What is the triangle ABC? It's here. You can form your triangle ABC here, right? You have to prove congruence in this and triangle BAD. Sorry, there's something here in this way. Okay, that's just the diagonals again. How will you prove it, beta? This and this sides are equal, correct? AD is
BC
equal to
equal.
BC. Yes, excellent. Then AB is equal to AB is common. 2 is done, correct? If two are done, and then one vertically opposite angles you can take. If this three are equal, then it is equal, correct? Correct, Laiba? When you have proven the
Yes.
congruence in these two triangles, then the diagonals will also be equal, right? Like because of the thing CPCT, correct?
Wait,
This is
basically
equal to,
one
yes.
um BC equals to AD, AB is equals to AB, and which is the angle?
Angles, vertically opposite angles, you can use it here, beta. VOI, vertically opposite,
Huh?
VOA. I'll tell you, you can use it in this way. If it is X, we know it already that the opposite angles that are formed in X form are always equal. You can use that. Or you can use any other thing also. You can use even the parallel thing. If you want, you can use AB, this angle. Or no, you cannot use the angle thing. You cannot use the angle thing because it's not Z shape. I think you can use it another way. Wait, I'll see how we can use the angle. I think you can use this angle and this angle. Yes, you can use this angle and this angle because it's no, it's you cannot use this angle. No, you're not supposed to use the angle there. You can use the vertically opposite angle only. Yes, Laiba.
So what will be the angle?
So the angle, this one angle OAD, this is equal to angle BOC because of the vertically opposite angle concept. Okay?
Yes.
And what more? What more? Angle. And what more did we discuss? This side and this side are equal, right?
Yes.
Right? Because it is
AD
given
equals to
already. AD is
BC.
equal to BC, and also this and this are common, right? AB is equal to AB. Okay?
Yes.
Okay, Alhamdulillah. Okay, next thing. Next, anything more to prove here?
AC is equals to BD
S
because
is equal to BD as a side. Yes, that's done. Okay,
ABC.
I think you can also use other angles as well here, beta. Which angle can you use here? Do you remember angle B? We proved angle B is equal to angle A. We can also use this angle. Yes, right? This angle,
Yes.
angle A, we can also use this angle. Correct? It totally depends on you. VOA is also applicable. You can also use vertically opposite angles. Okay? That is also a reason. If there is any x, then this and this are always equal. Okay? I've already told you in the first class of the triangles. Do you remember?
Yes.
Yes. So with that, we can use the postulate to two sides and one angle. Yes, A as postulate, and that will be sufficient.
So for the test, you're just gonna give questions from the exercise.
Yes, beta.
For the test, we're just gonna do questions from the exercise.
Yes, you want to do from the example problems?
No, fine. I thought you give some other questions.
Okay, you want to do other the problems? Probably you won't have the extra problems for your exams. Do you have the extra problems? Do you have to solve
You
the
mean,
extra problems apart from the that
mean,
are in the textbook?
oh yeah, they don't come from the textbook.
Yes, but almost all the problems will be similar, right? These concepts will
Yes.
be similar. Just the
Yes.
namings will change, and it will be
Yes.
almost same, almost same.
Yes.
Yes, right? Okay, Alhamdulillah. So you have to prove the midpoint theorem. You have to prove this now. Come on, please tell me how will you prove this midpoint theorem for me? How did we prove this midpoint theorem, Laiba? Laiba, please explain to me how did you prove this?
Um,
Okay, we have a triangle here.
yeah.
First, what did we do with it? We made a simple construction, right? What construction did we do? Laiba, please explain.
Um,
We are constructing something FD, right? Called FD, which should be equal to EF, correct?
yes.
And what more? This should be equal to this. And we are making a parallelogram, correct? And after that, this is just the construction part. After that, what we have to do here is we have to prove the congruency in this triangle and the other triangle, which are the two triangles in which we have to prove the congruency, beta.
AEF
And DCF.
FCD.
Excellent. These two triangles we have to prove the congruency. Kindly tell me what we'll use to prove the congruency.
Yes.
This is already known. EF is equal to FD is already known. Done. What else will we take to prove the congruency, Laiba?
AF is equals to DC.
EF is equal to DC. No, EF is equal to DF. That is done. Then this is parallel to this we had proved. So this and this are equal. Alternate angles, right?
Yes.
This is an alternate angle to this. Okay, what more, beta? This vertically opposite angles. So which postulate can we use? A? Yes. A. We can use A as a postulate as well. Or you can use SCS congruency postulate as well. How will you use SCS postulate here? How will you prove it? Because this is a midpoint, F is a midpoint. This is equal to this. Correct?
Yes.
Because we have already told that in a midpoint theorem, this should be a midpoint, right? This is a midpoint. F is a midpoint. In the midpoint theorem, what are you going to prove, Liba? What did I say? What you are going to prove? EF is parallel to BC, right? You have to prove EF is parallel to BC, and what you have to prove? EF is equal to half of BC, right? So these two things I are going to prove. First, you have proven the congruency in these two triangles. Triangles is done. Now what you have to do, beta? Because of CPCT, right? What comes into picture? This angle and this angle are
Equal.
Equal. If these alternate angles are equal, then we have to know that the sides are parallel to each other. These sides are parallel to each other. Okay. If angle A is equal to angle C, then sides are parallel to each other. If sides are parallel to each other, then the smaller sides, this AB is parallel to CD. Then if AB is parallel to CD, then the smaller sides are also parallel to each other, right? EF is parallel to DC. If EF is parallel to DC, then what more can we prove here, beta? Sorry, EB is parallel to DC. If EB is parallel to DC, this can we prove that this is a parallelogram?
Yes.
Because of CPCT, this and this are equal. We know it already.
Yes.
A is equal to DC. If A is equal to DC, then this is equal to this. Because we know that this is E is a midpoint. AE is equal to DC, right? A is equal to DC. Then B is equal to DC. If this and this opposite sides are equal now, right? Then we have proven that these two opposite sides are equal, and we also know that we had framed this one as a midpoint of this. It is already given. EF is equal to EF is equal to FD, and that should be equal to BC. That's already given. If this line is equal to this line already, this line is already now proven that these two are equal, then it is a parallelogram. And we also showed that this is parallel to this. If this everything is parallel, then ED is parallel to BC. Done? Isn't it easy?
Yes.
Yes. After that, what did we prove? How did we prove that it is ED is equal to EF is equal to half of BC? How did we prove EF is equal to half of BC? How did we prove it? We know that BC is equal to ED, right? ED, right? This line is equal to this line in a parallelogram, correct?
Yes.
So BC is equal to what is EF plus EFD? EF plus EFD, correct? Are you listening to me? I'm hearing some sound behind. Liba, everything is fine? Liba, I cannot hear you.
Yes. Yes.
Yes, everything is fine now. Okay, so
Yes.
BC is equal to EF plus EFD. Instead of EF plus EFD, you can write single EF, right? So EF plus EF you can write. EF plus EF, because these two are equal. EF is equal to EFD. So EF is plus EF, it becomes 2 times EF. 2 times EF is equal to BC. 2 times EF equals to BC. Then BC is equal to what? Sorry, BC by 2 is equal to EF, right, beta?
Yes.
So it is nothing but EF is half of BC. This is very important theorem. Okay, Alhamdulillah. Chalo. Can you solve two problems in this? You can pick the problem. Which problem do you want to solve in the exercise problems? This is done. Can you solve this? The sixth problem? I think I had given you the seventh problem as an homework. I want you to solve this, beta. Try to solve it. Try to solve it in your rough book and just send me the snapshot now.
Okay.
What do we know here is that there's a triangle A, A, B, C. Right angle triangle. HC, they have told you. Okay. A line through the midpoint of M. There's a line here. Midpoint of M. Hypotenuse and the V is parallel to BC. Okay, MD. There is an MD drawn here. You have to show that MD is perpendicular to CA. And also you have to show that CM is equal to MA is equal to 2AB. CM is equal, it's not 2AB, it's half AB, yes. It's half AB, as we had to remember that, okay. D is a midpoint of AC. You have to prove that D is a midpoint of AC. Happily prove D is a midpoint of AC. You just have to take one triangle, right? Triangle ACB. This whole triangle. We know that M is a midpoint already. And we know that D is also the midpoint. If these two are midpoints, then this through the midpoint theorem, we can prove that this and this are parallel to each other, right? Aliba, are you doing this, solving this problem? I cannot hear you.
Yes, I'm doing.
Yes, okay, alhamdulillah. So the D is a midpoint. You have to prove that D is a midpoint. To prove that D is a midpoint, we already know that M is a midpoint. So what do we apply here is nothing but the midpoint theorem. The converse of the midpoint theorem we can apply here. What does it state?
It's BC.
Yes, so this MD is equal to half of BC, right? That we can state later, but we are going to just show that D is a midpoint. How to show that D is a midpoint? Just by the midpoint theorem, converse of the midpoint theorem. If this and this are parallel, because it's given that this and this are parallel, we can just say that this is a midpoint, correct? And then what you have to prove was is this BMD is parallel to MD is perpendicular to AC. You have to prove if this is 90 degree, then something standing on the same, this one is equal, right? This angle and this angles are always equal. If this angle, if there are two angles that are parallel to each other, then this angle is equal to this angle. Yes, right?
Yeah.
Which is the third thing you have to prove. CM is equal to MA is equal to 2AB, half AB. How will you prove that? CM. You have to consider one triangle here. You're going to consider two triangles, right? Which two triangles will you consider, beta? Triangle AMD and the triangle CMD. This true triangle. From this two triangle, you have to show that CM is equal to MA. This CM is equal to MA. If CM equals to MA, what more? From the midpoint theorem, can we not prove that it is equal to half of AB? Then please send me the photo.
Right.
Yes, do it, please. Okay, done. We almost time.
Um,
Okay, are you done? Please send me this photo, okay? Snapshot of the solved problem. Okay, Alhamdulillah, we are done with this today's class. Okay. I'll just brief out about the statistics that we are going to study tomorrow. Just 5 minutes. Just 5 minutes more, okay? Okay, so we are going to discuss statistics tomorrow, bit, okay? Inshallah. So can you tell me what are the things that you have, concepts that you have in the statistics? Alaiba?
in this sixth one.
In the statistics.
No, actually, in the question I'm writing right now.
Okay, please. You want to
Yeah.
discuss about the problem. Okay.
For the third point, CM is equals to MA is equals to half of AB.
Hmm.
How do we prove that?
Okay, where were we? Bismillah. What did we have there? What was the question? I'll just share the screen again. Documents. Okay. Quadrilaterals. The sixth problem here, right? Okay. Okay, this was a problem in which you had to write a right angle triangle. This is angle C, this is angle B, this is angle A, and this is angle B. Okay, we can write B here, right? Yes, Alhamdulillah. Okay, we are going to write a line here, and there was a midpoint here, right, Vita? What was the midpoint called? Yeah. And from this, they had drawn an intercept, which is a D. Okay, we just have to prove that CM is equal to MA. So A is here, okay? B is here, okay. We have to prove that this is equal to this, and then we are going to prove that this is half of the AB, okay? Half of the side AB. First, we are going to prove the congruence in this and this. Let's consider triangle CDM and triangle DAM, okay? DAM और ये दो triangle consider करेंगे. इन दो triangles में which is common side बेटा? MD is equal to MD. Is it common?
Yes.
Yes, the first thing is done. The second thing, what is here? What is here in these two triangles? What you can prove, beta? Kindly tell me what you can prove in triangle. This one, triangle, which we are going to consider here. Yes, beta, what we can prove? Isn't M the midpoint here? Yes, right? So what we can prove here, beta? One thing is common, right? DM is equal to DM. This is done. Now tell me what else can we do here? We know ADM. What is angle ADM here?
Yes.
It is 90 degree, right? And what is CDM here? Because it is a straight line which is already given. If this is a midpoint of this, then it is standing on the straight line, right? So we can tell this and this is equal to 90 degree, right? Right? Right, Vita? So the angle D on the both sides are equal to 90 degree. CDM, because we have already proven it, right? MD is perpendicular to AC. Correct or wrong?
Yes.
So CDM is equal to MDA, which is equal to 90 degree. One side, one angle is done. What more we can do here, Vita? Because we know that D is a midpoint, what we can say? D is a midpoint. It is already proven. This is done. So CD is equal to DA. Is it right? CD is equal to DA. Yes or no? Yes. So one side, one angle, and one side. So it is the SAS postulate. Done. From the SAS postulate, this is proved congruent to this. Now we can say that CM is equal to MA. Yes or no?
Yes.
CPCT, right? So
Yes.
CM is equal to MA from CPCT. This is done. If this is equal to this, and we also know that this whole, it is AB, right? This whole is AB, and this is point. This point is a midpoint. M is a midpoint, right? So AM is equal to MB, right, beta?
Yes.
Yes. AM is equal to MB. Midpoint का मतलब क्या होता है? AM plus BM is equal to matlab they are equal. If this and this are equal, how we can write AM plus AB is equal to, what is AB equals to? AM plus BM, correct? We have to say that it is half of AB, correct?
BM.
Yes, so that's all, it's done. CM is equal to MA is already done. CM is equal to MA is already done. Now we can show that MA is nothing but it is half of AB, right?
Yes.
Yes, because it is a midpoint, because this is a midpoint, because M is a midpoint of AB, sorry, this one, M is a midpoint of AB, we can say that AM is equal to, CM is already done, but AM is equal to half of BM, sorry, AB, correct? If AM is equal to half of AB, but AM is equal to CM, then AM equals to CM equals to half of AB. Correct? All these equations are equal because this is equal to CM, AM is also equal to half of AB. So this is proven. Done? Was it easy?
Yes.
Any difficulty here? Just the congruence in these two triangles, and just to prove this and this sides are equal. If CM is equal to MA, then we also know that this is a midpoint of M is a midpoint of AB. So what is this? If M is a midpoint of AB, then this and this sides are equal. Then this whole is half of it, right? Half of AM, correct? Half of AB. Done? Done, Laiba? Okay, Alhamdulillah, we are done with the class. We do not have more time. So we'll quickly end this session. Inshallah, tomorrow in tomorrow's class, we'll be studying about the statistics.